at the two vectors with same magnitude. The second vector is obtained by rotating the first vector with an angle phi. So this is the angle phi. We can calculate the vector coordinate as Vn is equals to xn comma yn based on the input vector and the rotational angle phi. According to the law of mathematics, a signal can be represented with as xn is equals to x naught into cos of phi minus y naught into sin of phi. Similarly, yn is equals to y naught into cos of phi plus x naught into sin of phi. Reframing this equation and taking common cos of phi, we get xn is equals to cos of phi into x naught minus y naught tan of phi, because we need in terms of arctangent. Yn is equals to cos of phi into y naught plus x naught tan of phi. Assuming that we allow only the rotational angle of phi for tan of phi, for which tangent of phi will be 2 power of minus I, where the value of phi ranges from 0 to infinity. Since the aim of fixed angle rotation is to compute sine and cosine of the given angle using fixed number of iterations, so let's call this iteration as theta. Here these are the harmonic motions of the signal. A point on unit circle rotated by an angle theta. It has the coordinates of cos theta and sin theta. This says if a point on the x-axis on a circle is rotated by an angle theta, then the sine and cosine angle of the rotations may be directly represented from x-axis and y-axis of the unit circle. If the coordinates of the point on the circle may be represented as xy, then it can be equally represented as x bar and y bar for the transpose function. I am writing it to be xy whole bar. The rotation of a point may be effected by multiplying the coordinates through a specific point by a rotation matrix as cos theta minus sin theta followed by cos theta with a multiplier of input x comma y, for which the transpose value will be x bar and y bar. Let me consider this part to be an equation 1. Let's consider we need to compute a long translential computation delays with trigonometric functions as x bar is equals to some constant k I am defining into x of cos lambda plus y of sin lambda. Similarly, y bar is equals to constant k into y cos lambda plus x sin lambda. As said earlier, this k will be represent some constant value for which I am going to give a fixed angle of rotation. If that is so, similarly x bar and y bar are the coordinate for the x and y rotating at an angle theta, thereby obviously considering its units, we can again write it as x bar is equals to x cos theta minus y sin theta and y bar is equals to y cos theta plus x sin theta. This is with respect to the unit circle. I am assuming this part to be equation 2. Now since we are talking with respect to the fixed angle of rotation, theta n with the angle of sine and cosine signals, theta n, calculated an initial value of theta reaching at 0 by constant rotation. The angle of rotation for theta 1 to theta n makes the equation to be x1 bar is equals to cos theta into x minus y sin tan theta. Similarly, y bar is equals to cos theta into y plus x tan theta. Let me consider this part to be an equation 3. Thereby restricting this rotational angles such that it is transformed to a relation of a form tan of theta is equals to 2 power minus I. Let me be specific, plus or minus. This part of the multiplication by the tangent term can be reduced by a simple shifting operation, thereby reducing the hardware complexity.